Hi everyone, I'm Dr. Divya Kaur, and in this lesson we will learn how to determine the shape of the molecule using valence shell electron pair repulsion theory. This theory is based on predicting the structure by minimizing the repulsion between the lone pairs and the bond pairs. Now let's begin with the electron pair corresponding to 2. In order to have a minimum repulsion, the beryllium chloride bond pairs will be as far as possible, forming linear shape, and the bond angle will be 180 degree. Let's work on electron pair corresponding to 3. For example, BH3 molecule. When the 3 bond pairs corresponding to these will be as far as possible, the shape acquired will be trigonal planar, where the bond angle is 120 degrees. Let us look into the case where again you have 3 electron pairs, but out of 3, 2 are bond pairs and 1 is lone pair. Now in that case, for instance, sulfur dioxide, so what is happening is one side is acquired by lone pair and the other sides are acquired by bond pairs. It turns out to minimize the repulsion between this lone pair and this bond pair, it acquires bent shape, and the angle is 120 degree. Now let's work into the case when the electron pairs are 4. So in the first case, all are bond pairs. So for instance, this methane molecule. So it turns out the bond pairs corresponding to this methane will acquire a tetrahedral shape to have the minimum repulsion, and the angle will be 109.5 degrees. So this is the shape which is acquired when this molecule has minimum bond pair repulsion. Let's look into the case where again you have this one bond pair is now replaced by the lone pair. For instance, the example to be ammonia. So it turns out when the lone pair is being occupied by this bond pair, now the shape is now changed and it is pyramidal. So having one lone pair and 3 bond pairs, to minimize this repulsion, the shape will be changed towards pyramidal. So it's actually trigonal pyramidal structure. And in order to have this minimum repulsion, the angle also gets lowers down to 107 degrees. So let's work into again third case where lone pairs are 2 and bond pairs are 2. So again another bond pair is replaced by lone pair. So it turns out this water molecule is now acquired the bent shape. And why is that? Because this shape will have, the 2 lone pairs will have minimum repulsion with these 2 bond pair, and the angle is 104.5 degrees. So the shape is bent in case of water molecules. Now this is a case with 4 electron pairs. Let's have the structure with 5 electron pairs. And the first case will be all are bond pairs. So it turns out the shape it acquires is trigonal bipyramidal, where the 3 atoms will acquire this equatorial plane and other one will acquire the axial plane. So this is axial bonds and these are equatorial bond. And this is a shape which is acquired having this minimum repulsion. The angle between this bond pair is 120 degree and this angle between the axial and the equatorial is 90 degrees. Now let's work on the case. So this is a case for PCl5, phosphorus pentachloride. Let's work into the case where again one bond pair is replaced by the lone pair. For instance, the SF4 molecule. So what is happening is one of the equatorial is being replaced by this lone pair. And therefore the shape which it acquires is seesaw shape. So as you can see this molecule, it is having seesaw shape with again the one of the side of equatorial is replaced by the bond pair. Now let's look into the case where you have another bond pair replaced by lone pair. So in that case, we have 3 bond pairs and 2 lone pairs. Those 2 lone pairs will acquire again the equatorial side. It turns out the shape will now change to T shape in order to have the minimum repulsion between these 2 lone pairs and these 3 bond pairs. So this is the case of ClF3 molecule. Now let us look into the case where we have again 3 lone pairs and 2 bond pairs. So it turns out the shape is linear. Why? If we look into this molecule, the bond pairs acquires axial bonds and the other will acquire the linear equatorial bond forming linear structure. Again, the angle in linear structure is 120 degree. So this is a case for 5 electron pairs, out of which 3 are lone pairs and 2 will be bond pairs. So now let's look into the case where we have 6 electron pairs. So it turns out, for instance, this SF6 molecule, all the 6 will be acquired the octahedral shape and the angle will be 90 degrees. Now let's look into this case where one of the bond pair is now replaced by the lone pair. So it turns out the shape is now distorted. To have this minimum repulsion, this will have square pyramidal shape. So this molecule has square pyramidal shape. And now the angle is 90 degree between these at bond pairs. So this will acquire the shape when it has minimum lone pair and bond pair repulsion. This is an example corresponding to BrF5. Let's look into the case when we have 2 lone pairs and 4 bond pairs. So again, this is a case of 6 electron pairs where out of which 4 are bond pairs and 2 are electron pairs. So these will be acquired by this position and these 2 lone pairs will have minimum repulsions with these bond pairs. And therefore, the shape acquired is square planar. So, as you can see, depending on lone pairs and bond pairs, different shape are acquired based on minimizing the repulsion between the lone pairs and the bond pairs. So, I hope you like this video. Please like, share and subscribe, and thank you for watching.